In this video, we're going to look at a more conceptual example involving eigenvalues. So let's suppose that A is n by n, and A squared is the identity matrix. I want to show that the only eigenvalues A could have are 1 or negative 1. Okay, so how do we solve something like this? So what makes this a more conceptual problem is the fact that the actual matrix A isn't given to us. It tells us some property about A instead. It tells us that A squared equals the identity, and then it's asking us to somehow show that A has certain eigenvalues, in this case negative 1 and 1. So the way I'm going to begin is I'm going to let lambda be an eigenvalue of A, be an, I'll just abbreviate eigenvalue of A with some corresponding eigenvector with eigenvector x. Then what I'm going to do is I am going to multiply both sides of this equation by the eigenvector x. Then A squared times x equals the identity matrix times x. And the reason I'm doing that, the reason I'm multiplying both sides by x is that when I multiply the matrix A by x, I know that it equals something nice, because x is an eigenvector of A. Okay, so A squared times x specifically is A times x. And because x is an eigenvector of A, we know what A times x is. A times x is lambda times x. It's lambda times x, because x is an eigenvector and the corresponding eigenvalue is lambda. That's what we began by saying. So I don't know what lambda is at this point, but I'm just saying lambda is whatever the eigenvalue is, and I'm saying that x is its corresponding eigenvector. Okay, so now, let me give myself a little bit more room. Let's move this scalar lambda in front, and I get lambda times A times x. And then I have another copy of A times x, and I know what A times x is. So I know what A times x is lambda times x. It's showing up again. So what I have is lambda times x, which is lambda squared times x. Okay, so for that reason, A squared times x I now know is lambda squared times x. And on the right hand side, the identity times any vector is just that vector, so I just get x. Okay, so that first line implies we have this, and then this line implies, let's move everything over to one side. So I get lambda squared times x minus the vector x equals 0. Okay, so now I can factor out the x and get lambda squared minus 1 times the vector x equals 0. Okay, so something times something equals the 0 vector. And I know that the vector x is an eigenvector. This is an eigenvector, and we know that eigenvectors are supposed to be non-zero. So this eigenvector is non-zero. But if the eigenvector is non-zero, and this product is supposed to be equal to 0, this product of this scalar and this vector, well, that means that the scalar lambda squared minus 1 better be 0. That needs to be equal to 0. And if lambda squared minus 1 equals 0, at this point we can solve for lambda. We know that lambda equals plus or minus 1. So what we've shown at this point is if my matrix A has this property that A squared equals the identity, then the only possible eigenvalues it could have, the only possible choices for what lambda could be, are 1 or negative 1.